Hello everyone, welcome to another video. Now in this video we are going to look at another arrays medium level question. Now this question is nothing new. We have already learned all the concepts and we just have to use already used concepts in a logical manner. So basically we know how to access the matrix, right? And we also know how to sort an array. So that's it. That's what we are going to do. We are going to sort we are going to access the matrix in a diagonal manner, and then we are going to sort whatever the elements we find in that diagonal. Now how this is going to work, so let's do that here. So what the question is, like, we need to sort the elements in the matrix, okay, then diagonally. So what does that mean? So the first question, let's say we start from here, okay. So this is a single element. Single elements are always sorted, so we don't care about that. So this is done. Sorry, this is done. Now we have 1 and 2, they are already sorted, okay. So this is also done. Now we have 3, 1 and 2, okay. 3, 1 and 2, if we sort this, it will become 1, 2 and 3. Sorry, 1, 2 and 3. So that's what we need, 1, 2 and 3, okay. Similarly, we have 3, 2, 1, we want 1, 2, 3. We have 2, 1, we'll sort it to 1, 2, and at the end single element are always sorted. So that's what we want to do here. But how are we going to do this? Since we need to access each element and we need to sort it, but we can do it like in many different ways. So one of the ways that we are going to see is we'll create another function that will take a matrix, okay. They take the diagonal elements of a matrix and sort them. So this is a little bit sort of a bucket sort that we are going to use, okay. So we'll see, let's see the how we are going to solve that. So the first thing that we need over here, let me write this again. Let me remove this and write this again, it will be better. So this is 3, 3, 1, 1, yeah, 3, 1, 1. Then we have 2, 2, 1, 2, and we have 1, 1, 1, 2. So what we are going to do is that we will start from here, 0th index, and we will access each element, like each diagonal, okay. We'll start from I equals to 0, j equals to 0, okay. So the first thing that we are going to do is that we will have two loops in which we will access the helper function that we are going to create. In the first loop, what we are going to do, we'll keep the I as 0 only, okay, and we will only change our jth index, okay. So what does that mean? What will that do is that we'll have first of all we'll be able to do this, like this diagonal, then this diagonal, okay, then this diagonal, and then this diagonal. If you can see here, the I is constant in all of these, okay. I is 0 and we are only changing the jth column, okay. The second element comes here, the second is here, the second is here, like that. And in the second time, what we'll do, we'll keep the jth index as 0 and we will change our I, okay. So what that will do is that the elements that are left by in this L portion below this, okay, we'll be able to access that. So if you'll see, let me change the color, it will be good. So if we'll see here, we have 2, 1, then we have 1, okay. So we are saying, if you can see, we are, okay, again, yeah, we are changing the j over here. J is constant, I'm sorry, we are changing the I over here, okay. If we'll see, j is 0, this is j equals to 0, okay, 0, 0, 0, like that. And this is what we are going to do. But how are we going to achieve this? This is the step 1 of our algorithm, okay. This is the first step. The second step is that we will, whatever the index that we find, okay, whatever the value that we find, let me write it again, this is very time consuming. Okay, so what we'll do is that whatever element we come by, okay, let's take this diagonal. So we have 3, 2, 1. We'll create a temporary array, okay, and in that, whatever the element we encounter, we'll increment that value that at that index in our temporary array. So we have 0, 1, 2 and 3. So we have found 3, so at index 3 we'll increment. We have found 2, at index 2 will increment. We have found 1, at index 1 will increment, and this is going to remain 0. Okay, so after this, if you can see here, we have this temporary array, right? So we'll go through this temporary array, okay, and we will see wherever we found a value greater than 0, okay, we will add it to our matrix in that particular I and j index. Okay, so by doing this, what we'll get is that first value that we encounter is 1, then we encounter 2, then we encounter 3. So in this way, our diagonal will be ready. Okay, so I know it is a little difficult to catch up, like what we are doing and how we are going to achieve this. Okay, but this is just the theory part. Okay, you'll be able to understand this more clearly when we do the code. So let's jump into the code and start with that. So first, let's create this helper function that we are talking about, right? So I'll put it public only. Okay, let me name it as helper. Okay, we need 3 things. Okay, first is our matrix, second is our row, and third is our column. Okay, another thing that we need over here is our temporary array. So let me create that as well. Now what is going to be the size of this? This is going to be the maximum value that we can find in our matrix, because if we find if we give it some less value and if we find some bigger value in our matrix, that will give us array index out of bound error. So to avoid that, what we'll do, what is the maximum value that we have over here is 100. Okay, so to access the 100th element, okay, we need size of 101. Okay, this is done. Now another thing that we need to take care of it over here is that we will be requiring this row and column index quite frequently. Okay, first of all to get the values from matrix, and secondly when we are trying to sort the matrix using the values that we got from temporary array. So for that, what I'll do, I will simply store it in some different variable. Okay, that way we can use it again and again. Okay, so first thing that we need over here is that we need to add whatever the elements that we find, okay, in our temporary array. Okay, now why I'm using this while loop, not for loop? Because we need to check. Let me show you over here. Let's say this is the matrix that we are trying to achieve. Okay, and let's say you start from here, you go here, you go here. Now if you will see, we still have the j left, right? J is still, let's say I is equals to 3 here and j is equals to 4. Now this index is I equals to 3, j equals to 3. Okay, we need to break the loop whenever we whenever I is greater than this length, okay, matrix length, and j is greater than the size of our column. Okay, so I'm sorry, the size of the row, because whenever we are trying to do that, if we go out of that, then it will obviously give us array index out of bound. So what we'll do, okay, while I is less than the length of our row, okay, and j is less than the length of our column. Okay, what I will do is that in temporary array, at what position, matrix ij, I will have to increment this matrix of ij. This will give me the element that will serve as the index for temporary array. Okay, and then we'll increment that position. Now we also need to increment I as well as j, because we are trying to do only the diagonals. Okay, so we need to increment both of them simultaneously. But this looks a little bit messy, so I will be writing over here, and I will remove this. What happened? Better. Okay, so now our temporary array is ready. Okay, now we need to access this array, and we need to store whatever the values we find in our matrix. But by doing in this step, in this while loop, our I and j are changed. So let me again set them to what they were. Okay, now let's go through our temporary array I, j, k is available, right? So we'll start from 1 because 0 is going to be always 0, so it doesn't make any sense. Then we go to, okay, I less than 101, I, not I, k, I think, k less than 101, k plus plus, okay. Now, one more thing that we need to take care is that it is not necessary that all the values that we encounter are going to be unique, okay. If you will see, it is possible that, let's say this is a matrix, okay, we have 1 1 2, or let's say we have 3 3 2 and another is, let's say, 1, okay. In that case we have 3 multiple times, okay, and it is possible like we can encounter. So what we'll do is that while temporary array at index k is greater than 0, okay, what we'll do, matrix ij that is going to be equals to the index that we find, okay. Now we have seen one element, right? Let me remove all this. So we have, let's say, 3 3 2 1. Now we have seen this 3, we need to decrement this. So what I'll do, temp at index k, decrement. Now we are going diagonally, so I plus plus, j plus plus. Now as you can see, like I don't like writing like this, so I'll increment here only, so this goes away. Now temp of k minus minus, that is also looking not nice, so I will decrement in the condition only, okay. So our algorithm is almost ready, okay, but as I said in the first room, in the beginning, okay, we need to encounter all the elements, okay, we need to encounter all the elements. So first thing is that we'll keep I equals to 0 and we'll keep changing j, okay, and the second time we'll keep j equals to 0 and we'll keep changing I. So for that what we'll do is that for I equals to 0, I less than matrix of 0 dot length, is it okay, let me see, okay. Here what we'll do, we'll call the helper function, we'll give the matrix. Now I, that is going to remain 0 and j will keep on changing. The same thing we are going to repeat over here, okay, but this time we'll start from first index because 0th index we have seen everything, right, and this time we are going to the columns, right. So what I'll do, plus plus, okay, let me, so okay, this is not correct, I think this is going to be matrix and this is going to be, I think, 0 because we are changing the rows and columns and everything, yeah. So this is helper matrix, this time we are changing j, okay, and j is remaining constant and we are changing I, okay, and at the end I'll simply return matrix, okay. Let me first run this because I'm not sure, like if this is correct, okay, yeah. So this is going to be 0 as I said earlier, and this is going to be the matrix, okay. Now let me run this. Okay, this is I'm sorry, this is the issue over here, we forgot to increment our j. Now let me submit this only directly. Now I don't think we have any other issue, yeah. Okay, so as you can see, it's really that simple. I know I made a lot of mistakes over here, but at the end we were good, okay. So yeah, that's it for this video. I hope you like this, and let me do one thing. The time complexity over here, I will leave it to you, and you try to calculate the time complexity on this algorithm, and do let me know. Like, submit your whatever you find in the comments, and try to find the time complexity over here. Okay, so you can see, like, for this I will give like one suggestion. You can consider this mat ij as k. Okay, so like we have 1 less than equals to m, and n is less than equals to 100, right? So for this you can consider as k, mat ij as k, and you try to find the time complexity of this algorithm that we have done over here. Okay, so that's it for this video. I hope you liked this and understood this, and you learned something new. Okay, and do let me know if you have any other problems for me to solve from any other platform. I will see you in the next one. Till then, keep coding.